Look at that roof. It looks almost ordinary, doesn't it? Just another enormous industrial building sitting somewhere outside a major city. There are no skyscrapers, no futuristic machines visible from the outside. Nothing that immediately tells you this building could be worth billions of dollars. But behind those walls, something extraordinary is happening. Thousands of machines are working around the clock. They are consuming enormous amounts of electricity, generating tremendous amounts of heat, and performing billions of calculations every second. And what they're doing inside that building could help determine how quickly artificial intelligence develops over the next decade. This is the hidden physical world behind AI, and its scale is growing at a remarkable speed. For years, the internet depended on data centers like these to store information, host websites, stream videos, and keep online services running. But artificial intelligence has changed what these facilities need to do. Traditional data centers were designed to handle many different types of digital workloads. AI requires something much more demanding. Massive amounts of computation happening simultaneously. That's because modern AI models aren't simply retrieving information from a database. They are performing enormous numbers of mathematical operations to understand language, generate images, analyze information, and produce responses. And those calculations require specialized processors. Walk inside a modern AI facility, and you'll find rows of server racks packed with powerful GPUs. These aren't ordinary computers sitting on desks. Thousands of them can be connected together, working almost like one enormous machine. One processor handles part of a calculation. Another handles another part. Thousands more work alongside them. And all of those machines have to communicate with one another incredibly quickly. That's why the inside of an AI data center looks less like an office and more like a carefully engineered industrial system. There are kilometers of cables connecting machines together. Specialized networking equipment moves enormous quantities of data between processors. Power systems deliver electricity continuously. And sophisticated cooling systems remove the heat produced by all that computing. Because there's a problem hiding inside every one of those server racks. The more powerful the computers become, the more heat they generate. And the more heat they generate, the harder it becomes to keep them operating safely. This is why building an AI data center isn't simply a matter of putting thousands of computers inside a large warehouse. The building itself has to be designed around the computers. The electricity, the cooling, the networking, and the enormous amount of data moving through the facility every second. And as AI models continue becoming larger and more powerful, companies are building facilities on a scale that would have seemed almost impossible only a few years ago. But there's an even bigger question. If these machines require this much infrastructure today, what happens when billions of people are using AI every single day? Because the buildings we're looking at now may only be the beginning. The strange thing about these buildings is that their size is only part of the story. The real challenge is what they consume. A modern AI facility can require enormous amounts of electricity just to keep its computers running. And unlike a normal office building, the demand doesn't disappear at night. These machines can operate around the clock. Every calculation creates heat. Every server needs power. Every processor needs to communicate with thousands of others. And all of it has to happen without interruption. That creates an engineering problem that is becoming harder as AI gets more powerful. For years, traditional air conditioning was enough to keep most data center equipment within safe operating temperatures. But the latest AI processors are different. They are far more powerful, and that power comes with more heat. So engineers are increasingly turning to liquid cooling. Instead of relying entirely on air to carry heat away from the processes, specialized systems can move liquid much closer to the source of the heat. The result is a data center capable of supporting much denser computing. But cooling is only one part of the problem. There is also the question of how all these machines communicate. Training a large AI model can involve thousands of processors working together. If information takes too long to travel between them, computing power is wasted. That's why AI data centers require incredibly fast networking systems designed specifically for massive computing clusters. The objective is to make thousands of individual machines behave as though they were one enormous computer. And then there's the electricity. A facility can have the world's most advanced processors and the most sophisticated cooling system ever built. But without a reliable supply of power, none of it matters. This is one reason AI companies are increasingly interested in where their data centers are located. They're not simply looking for cheap land. They're looking for access to electricity, fiber optic networks, water, or alternative cooling resource, skilled workers, and reliable infrastructure. The location of a data center can determine how quickly a company can expand its AI capacity. And that's becoming a major competitive advantage. Because the companies building AI systems aren't just competing to create better models anymore. They're competing to secure the physical resources needed to run those models. More processors, more electricity, more cooling, more networking, more buildings. And that is creating an extraordinary construction boom around artificial intelligence. Entire campuses containing multiple data centers are being planned. Some are expected to consume as much electricity as small cities. Others are being designed specifically around the next generation of AI processors that haven't even reached the market yet. The most remarkable part is that many of these facilities are being built before we fully understand how much computing power the world will eventually need. Companies are effectively betting billions of dollars on one assumption. That demand for artificial intelligence is going to keep growing. And if they're right, today's massive AI data centers could eventually look small. But there is something even more important happening behind the walls of these facilities. They are changing what we mean by a computer. For decades, a computer was something you could put on a desk. Now, some of the world's most powerful computers are entire buildings, thousands of processors, miles of networking cables, industrial cooling systems, massive electrical infrastructure, and enormous amounts of capital. Together, they form the physical foundation of artificial intelligence. And the demand for this infrastructure is only increasing. As AI becomes part of search engines, workplaces, healthcare, finance, entertainment, and everyday life, the number of calculations being performed around the world will continue to rise. That means more computing capacity will be required. And more computing capacity means more data centers. But building them isn't easy. A new facility can take years to plan and construct. It may require new power infrastructure, specialized cooling systems, and high-speed connections to the internet. And once it is finished, the technology inside can begin becoming outdated surprisingly quickly. That's because AI hardware is advancing at an extraordinary pace. A processor that represents the cutting edge today may be replaced by a much more powerful generation only a few years later. So companies have to design these facilities with the future in mind. They aren't simply building for today's AI. They're trying to predict what AI will require 5 or 10 years from now. This is why the AI infrastructure race has become much bigger than technology companies. Construction companies are involved, energy companies are involved, Semiconductor manufacturers are involved. Networking companies are involved. Cooling specialists are involved. Real estate developers and infrastructure investors are involved. An entire industrial ecosystem is forming around artificial intelligence. And that may be one of the most important things to understand about the AI boom. The biggest opportunities may not always be found in the companies creating the AI products that consumers see. Some of the most important businesses could be the ones quietly supplying everything those companies need to operate. The buildings, the chips, the electricity, the cooling, the networks, the land, and the capital. When we look at artificial intelligence from the outside, it can feel almost weightless. You type a question. An answer appears. You generate an image. It appears on your screen. You ask a model to analyze thousands of documents. Seconds later, the work is done. But behind that simple experience is an enormous physical machine. A machine that is still being built. And perhaps the most interesting part is that we don't yet know how large it will eventually become. Because if AI really does become as important as the internet, electricity, or the smartphone, today's data centers could represent only the beginning. The future of artificial intelligence isn't sitting in the cloud. It's being built on the ground. One processor, one power station, one cable, and one enormous data center at a time. If you enjoyed this documentary and want to understand the technology, business, and infrastructure shaping tomorrow's economy, subscribe to Future Capital. Every week, we go beyond the headlines to uncover the companies, industries, and hidden systems building the future. If this documentary changed the way you think about artificial intelligence, let us know in the comments. And if you want to see where this technology goes next, subscribe to Future Capital. Thanks for watching, and I'll see you in the next documentary.